Okay. So let's pretend that I didn't teach 27 of you Math 10. Because, of course, if I asked you to graph this equation and you had been in my Math 10 class, of course you recognize that slope-intercept form and you would graph it in 2 seconds, right? But let's pretend you've all forgotten what slope-intercept form means. But you would never forget that because I taught in 27 of you and you all remember it. So if I asked you to graph this, most likely, most of you would go to the old T-chart from grade 6 and put in some numbers, right? Right? You'd choose 3 or 4 numbers, you'd put them in, and it would make a nice line, right? And it would go from there, and it would look like that, right? Everyone remembers this, yeah? Okay. In grade 10, we did lines. In grade 11, the first thing that happened in grade 10 is those things morphed from y equals 2x minus 3 to f of x equal 2x minus 3. And you remember that this is the exact same thing. X is your input or your independent variable. F of x is your output or your dependent variable. And it's the same as y. We all remember this, yes? Okay. In grade 11, we are going to move to this. Okay? Now, if I wanted you to graph this, what would you do? Well, you would probably go ahead and make another T-chart, X, Y. You'd choose 3, 4, 5 numbers. -2, -1, 0, 1, 2. When X is -2, what's Y? He waited patiently for people to square -2. Thank you. When X is -1, what's Y? 1. When X is 0, what's Y? When X is 1, what's Y? 1. When X is 2, what's Y? 4. And you would get this. Okay? This is grade 11. What's the only difference? What's the only difference? Oh, my little light didn't come over here. What's the only difference between the equations? Pardon me? Okay, well, silly to go with that. What's the same between the two equations? We'll try that. There's an X and a Y. Excellently done. Now, what's different between the two equations? The X is squared. Excellent. Good. Now, if something happens once in math, how often does it happen? Always. So if squaring an X gives me this U shape, which is called a parabola, we'll come to that later, then what would it mean no matter what I wrote here? If the equation was this, and I graphed it, what shape would it have? A U shape, right? How do you know that? Because if it happens once, it always happens. When we square X, we get this U shape. Everybody cool? All right. Keep this in your head. I didn't make you write it down. We'll be writing it down later. But I want this in your head for a reason. You've all seen it now. Keep it there. All right? Now, we'll go to your books, and we will go to page 71. I was right, first try. This is all the stuff we're going to cover this unit. Now, you will notice you have already seen that this year, right? It's trinomial. We've been factoring them for the last unit, yeah? And you have seen that trinomial equals 0. We've been that's what we were doing at the very end of the unit with radical equations, right? What you haven't seen is graphing, vertex, x and y intercepts, and axis of symmetry, all of which we are going to cover, but not right now. The first thing we are going to talk about is solving quadratic equations. Now, you have already done this, as I said, so it won't be a problem, and it's a nice review for your test tomorrow, all right? So the first thing we need to talk about is what indeed is a quadratic equation. Well, we know what an equation is, right? What's an equation? Right. It's a mathematical expression that equals another math expression. And they all have, well, they don't all have, but they have the possibility of a solution. Okay? Now, if I do this, x squared plus 7x plus 12, is there a solution to that? What does the word solution mean? What does the word solution mean? Because, Jorah, you're right, there is work I can do with that. But what does the word solution mean? If I'm seeking the solution to a problem, what am I looking for? The answer to the problem, right? So if my problem is I can't find my shoes, the solution would be I find my shoes, yes? Because I don't know where they are. So, what in this case is unknown? The value of x. Can you find the value of x here? No, you cannot. Why? Because all you can do is factor it, right? All you can do with this is what Jorah said, x plus 3, x plus 4, correct? Still don't have an answer. Do you know what x is? No. If x was 7, the answer here would be 110. But we don't know if x is 7. If x was 3, the answer here would be 42. If x was 1.9, it would be a weird number, yes? Because this is an expression, it cannot be solved. All you can do is change it around. Kind of like 1/2 is 2/4, is 3/6. It's the same thing, it's just changed in how it looks. Everybody understand? Now, if I do this, now what do I have? Now I have an equation, which means I can find a solution. And this is where we were working yesterday and the last bit of the unit. Because this would now equal 0, and we would be in business. Right? Everybody cool? Okay. Now, that covers equations. But there's two words here. Quadratics. A quadratic has an exponent of 2 with, not with, I just put with and the together, with the independent variable. Now, it's math class, right? So while I am teaching you this, I'm going to be using x's and y's, like always. Which of those is the independent variable? You got a 50-50 shot. Someone take a guess. Jack? X is the independent variable. So in our class, it's going to be x. For now. Why did I specify independent variable? Because in physics, you deal with quadratics. In chemistry, you deal with quadratics. In statistics, you deal with quadratics. In social studies, you deal with quadratics. So I don't want to say it's always x, because it isn't. If we're doing a physics problem, you might be looking at distance and time, right? Or acceleration and time. Or growth and time, if we are looking in social studies or biology. So we need to be aware that it is not always x. It is the independent variable, and it is squared. Everybody cool? So, a reminder. Expressions, all you can do is simplify. Equations you can solve. Everybody cool? All right. So, solving by factorization. This is what we have just been doing. We just did it for the last couple of days with radical equations. This lesson is helpful to do now before your test on that because it will remind you of how to do it. So you already know how to do this one. A zero product property. That means if I have A times B and they equal 0, what do I know about this right now? Pardon? A or B equals 0, no matter what, right? Because A is a factor, B is a factor 2. And factor times factor equals 0. That means factor 1 must equal 0, or factor 2 must equal 0. Not 2, idiot, 0. Right? And no matter what is written there, that is true. And we have done this to death, right? Now, there's easy ones like this. What's the answer to that one? Six and 2. X plus 6. X plus 2. That's not the answer, though. What's the answer? Negative 6 and negative 2. Right? Everybody cool? Easy peasy lemon squeezy, yeah? Okay. What about this one? No, that's no good. That's no good. Sorry. There. What are you going to do with that one? Negative 9 and negative 2? Oh, the answer. Okay, yes. Okay, so Jashin has factored out and given me the answer already. Because it is not quite negative 9 and negative 2. It is x plus 9 and x plus 2, absolutely, except what? What did he forget to do? Noah. He forgot to divide by 2. So the answer is really x plus 9 halves and x plus 1, yes? Now, when we're factoring, we got to move this, don't we? Right? Because the factoring answer here is 2x plus 9 and x plus 1, correct? But we're not factoring because we had an equal sign, yes? So we can actually do the solution. So when we're here, we can stop. If it happens once in math, it happens always in math. 6 and 2, the answer is the opposite, right? So here, what's the answer? What does x equal? Negative 9 halves or negative 1. Is everybody cool? Yeah? Everyone's good? Okay, now, remember how I said I wanted you to keep that graph thing in your head? This has a square, right? Which means if I were to graph this, either one of these, I'd make that shape, wouldn't I? Now, what is that 0? Is that a y or an x value? That's a y value because it's a dependent variable, right? Now, please notice, 6, negative 6, negative 2. What are those values? X. And those are values of x when y is 0, correct? So, those values must be these values. Does everybody understand that? So, for that first one in red, if I were graphing this, it would be over here somewhere. Because negative 6 and negative 2. Right? If I were graphing this guy, which I wrote in blue, negative, negative, Negative 4.5, negative 1. It would be somewhere over there. Everybody with me? I'm going to teach you how to do that. I just want to start planting the seeds of all the stuff that you already know to show you how it's going to apply when we go a little bit further. Everyone's still good? Because we haven't seen anything new, have we? Nothing new yet. Turn the page over, and of course, these should take you about 3 seconds to solve, each one of them, right? What's this first one? X minus 7, x plus 2. So what does x equal? 7 and negative 2. This one. Remember, we're not necessarily factoring it all the way down. We're just trying to find the answer. So what's it going to be? X plus 5 over 3 and x minus 3 over 3. So what is the answer? Negative 5/3 and positive 1. Everybody cool? And the last one, of course, is, let's go gray, x plus what? 2 over 4 and x plus 2 over 4, which is x equals negative 1/2. Everybody can do these, right? Easy peasy. And it's good practice for the last part of radical equations, yes? Right? Okay. What is different down here? Anything? Look closely. There is a difference. There's a difference in some of those. Pardon me? Different letter. So if I were graphing this, f, for example, what values would go along here? B values. Everybody understand? Great. There are 6 questions there. Do them. Does it matter if you take slightly longer than I do? No, of course not. Couldn't matter less. But we all know that we're going to factor those, and that's going to give us the answer. Yeah? Everyone's cool with that, right? Okay. We are going to skip over these next ones. Those are going to be the first bit of work you do. Okay? We're going to skip over those because you know how to do them. It's just that higher level of factoring, right? I want you guys to go to 73. Looking at this, and I say to solve it by factorization. Now think about the end of the radicals unit. Jack?
Wouldn't you just move everything to one side?
Absolutely. You would do what you already know how to do. You would move everything to one side. Because right now, this is ugly. Everything's all over the place. So always, you can simplify things by moving them all to one side. So that would get us 8x squared minus 10x. Then what? Minus 3 equals what? What did I leave over here? 0. And now we can solve it because we know how to factor these. We would do 8 times negative 3, and we would have to multiply to negative 24 and add to negative 10. What is it? You'd think it was 6 and 4, but it's 12 and 2 because it's got to be negative, right? So it's going to be x plus, x plus 2 over what? 8, and x minus 12 over 8. What do I do every time I see a fraction? Simplify to get what? 1/4 and 4 over 2? Dude. 3 over 2. So what is the answer? X is negative 1/4 and positive 3/2. Easy peasy lemon squeezy, right? Right? We already know how to do it. What about B? I'm going to do the same thing, but what's in the way? Brackets. So I got to go back to grade 9 when I learned how to deal with these brackets. How do I do that? I distribute. And I get x squared plus 10x equals 4x minus 8. And now all of a sudden it looks like something I can deal with. Why am I able to do this? Because all the math I've ever learned is available to me at any time in this year. That is, of course, going to get me x squared plus 6x plus 8 equals 0, which is x plus 4 and x plus 2 equals 0, which means x is negative 4 and negative 2. Everybody's good, right? Again, nothing new. Right? Okay, we're going to skip those 4. You're going to use them to practice when I shut up. Those 6, we're going to use them to practice when I shut up. You're going to turn the page over to 74. Now, ladies and gentlemen, you know, most of you, the vast majority of you, know how much I hate math class questions like this, right? I hate them. I despise them. However, they are very useful because they make your brain do what it is supposed to do. You would never do this in real life. This doesn't happen. If you had a right angle triangle, you would measure it and do what with it? Pythagoras or the other thing, SOHCAHTOA, right? That's what you'd do. Because there wouldn't be a side that was x plus 2. You would measure it and you would say that's 6, right? But we're going to use this, as always, to train our brains to think effectively in math. So let's have a look at this. Of course you know what a right angle triangle looks like. It looks like this. Which of those sides is the shorter one? Because you want your drawing to look like something you can work with. X plus 2 is probably going to be the shorter one, yes? So here we're going to have x plus 2. What's going here? 5x minus 3. And what's going on the hypotenuse? 4x plus 1. This is a right angle triangle. I want to know what x is. What do I know about right angle triangles? You know Pythagoras' theorem, which if you've been in my class, you know how much I hate a squared plus b squared equals c squared. But that's how you all know it, so that's how we'll use it. What is a? X plus 2. What is b? What is c? And what do we know about x plus 2 squared plus 5x minus 3 squared? What does that have to equal? 4x plus 1 squared. Now, doesn't that look exactly like the last thing we did? And by exactly like, I mean, wasn't it some math I had to do on one side of an equal sign with some math I had to do on the other side of an equal sign? Of course it is. And then once I've done all that math, all I do is I go back to grade 10 and I solve it. Right? Now something weird's going to happen here. So start solving. This first one is, of course, going to be x squared plus 4x plus 4. And the next one is, of course, going to be 25x squared minus 30x plus 9. And that is going to equal Now, I know a great many of you are copying this down. That's fine, but you all know how to do it, right? What would be my next move? Get everything on one side, because I can see, even if I don't know anything about quadratics, I can see I have like terms. One sec. What? No, because it would be 4x plus 4x. Well, because it's 4x plus 1 times 4x plus 1. It's going to be 16x squared. 4x plus 4x is 8x. And 1 plus 1 is 1. Right? Even if you don't know what you're talking about, right? Even if you don't know where you're going, you can see like terms, collect them. And what is that going to give us after you've done all your collection? You guys go ahead and collect it. Tell me what it's going to give you. Jack. 10x squared minus 34x plus 12 equals 0. Now, you go back to grade 10, like I said. What are you going to do with that? The first thing you're going to do with that, the thing you should always do in big capital letters with the thick felt. GCF, what is it? 2. So right away we'll GCF it, and now we've got 5x squared minus 17x plus 6 equals 0. Yeah? Now what are you going to do with that? Find something that multiplies to 30 and adds to negative 17. What is it? Negative 15 and negative 2. X minus 15 over what? 5. And x minus 2 over what? 5. There's my answer. So what are my answers for x? What does that simplify to?
3.
Negative 3. So my answer is
3.
Positive 3. And this doesn't simplify. So my other answer is positive 2/5. Everyone cool? Okay, now that is the math you have been taught, right? Now that tells me that x is 3 or plus or 2/5. Yes? Now, using your brain, How many answers can there be for x in this situation? There could be two answers. This triangle could be two different things. There could only be what? One answer, right? So how do we determine which of those is the right answer? Plug it back into the equation. Which equation? We know it's going to work in this equation because those are the roots that worked. So where can I plug these two x's? Because I know that it's going to work there because this all proved that. So where's the other place I can check? Where else do you see x's? He waited patiently. Noah, in the triangle. Because x plus 2, 5x minus 3, and 4x plus 1 all have x's in them, don't they? So if I am going to check this one, what does this equal? 5. What does it equal here? And what does it equal here? 13. It's supposed to be blue. Does it work? Okay. Now, those are the yellow ones. Now what happens if I run that one through? What's 2/5 plus 2? Oh, geez. It's 2 2/5. Oh, sure. What's this? What happens to the 5s? Cancel, leaving me with 2 minus 3. What's that? -1. How can that distance be negative? Can it be? No. So is 2/5 a real answer?
No.
What did we learn to call that answer? An extraneous root. Right? So x had to be 3. Is everybody cool? Nothing new except applying logic to the situation. Right? Noah knew to check these x's because they're still x's. So we checked them all and we got an answer that couldn't possibly exist. Right? There's lots of things that can't be negative. Correct? Right? Could I have negative people in this room? No. So if I was doing some sort of quadratic with the amount of people coming into the room, and I got a negative and a positive as my possible values for people, which one would I automatically throw out? The negative, right? Can I have a negative speed? No, I cannot. Can I have a negative height? No. Everybody understand? All the stuff that you bring to the party is available to you here. I'm going to shut up my face, and you are going to work on those 6 and 6, 12 factoring questions that I asked you to do. There you are. Everybody should be okay with page 72. I think this is. Yep. It's just factoring. There's the answers. The only thing I didn't do was the last step, right? Yeah, the next 3 days of the book and the videos.
Oh.
I'll see the future and see how far ahead we get. I can't.
Mr. Sudu told me to come here. So.
Yes, I know Mr. Sudu told you to come here, but you've been in the class. How can I possibly know what is going to happen? If you guys figure it out, then we will go further.
I guess, sure.
Right? Watch the videos. That's what they're there for.
I got you.
Okay.
Thank you.
Goodbye. Suspensions are the worst. If only there was a way to avoid them. Oh, right, following the rules that the whole school is told all the time. Huh. Wow. Science! All right. Everyone's good, yeah? And of course, we stopped at the last step because we're not factoring this time, right? We're just seeking the answers. So in A, when you did all your work, you ended up at x plus 4/3 and x minus 1/2. And that's where you stopped. In factoring, we would have moved those to the front, but we don't need to, okay? Now, just for argument's sake, if we did move these to the front, and 2x minus 1, that would still equal 0, wouldn't it? Right? And 3x plus 4 would have to equal 0, or 2x minus 1 would have to equal 0, yeah? Right? So then we'd solve. 3x would equal -4, so x equals -4/3. -4/3. 2x would equal 1, so x would equal +1/2. +1/2. That's what's actually happening here. But because you guys have done so much factoring, I'm letting this last step go and just letting you stop here. Because you already know this line and you know this is A, this is B, and you know A times B must equal 0. Everybody understands why we can stop at this spot, yes? Everybody? Okay. Have people finished these tougher ones yet? No? Okay. Go ahead. Now, are these tougher ones that you want to see actually worked through? I assume especially E and F. All right. So by my assumption, are you okay with A, B, C, D? Can I just put the answers up for A, B, C, D? All right. So let's do that. The answers for A, B, C, D are A is -5 and 4. B is -2 and -2/3. C is -3/2. And D is 25/2 and -2. Everybody okay with A, B, C, D? If you don't have them done, like, obviously, but if you've got them done, everybody's got it? Everyone's comfy? Or does anybody want to see A, B, C, or D? I am here for you. Jack, you would like to see D. Okay. So D So what I would do with this, 2a squared minus 25 equals 21a, right? Because a, right? 2a squared minus 50 equals 21a. 2a squared minus 21a minus 50 equals 0. Yeah? 2 times negative 50, I got to multiply to negative 100. And I got to add to negative 21. So it is a plus 4 and a minus 25 over 2. 25 halves, that simplifies to 2. Everybody cool? Because, of course, a great many of you probably wanted to distribute this 2 in there right away. Right? So you would have had 2a minus 10 times a plus 5, yes? Which would have given you 2a squared plus 10a minus 10a minus 50. They disappear. 2a squared minus 50. 2a squared minus 50. You got the same thing. It just took longer. And more importantly than it took longer, it gave you a chance to screw it up. You notice that the first thing I did was here, right? Because that's the difference of squares. We know that's going to be a squared minus 25. And then this distribution is easier. Why am I allowed to do that? Because multiplication is commutative. 3 times 2 is the same as 2 times 3, right? So 3 times 2 times 4 is 24, yes? But 2 times 4 times 3 is 24. 3 times 4 times 2 is 24. Order doesn't matter. So I did the one in my head that was easier to do. Everybody cool? If you are going to do the long way, you just have to make sure you write the answer out carefully. All of you, well, 27 of you, 26 of you, were in my grade 10 class and have seen this is how I like to do FOIL. I like to stack it up so it's easy to collect your like terms. Most of you, if you had other teachers, were taught to write FOIL out in a straight line, plus 10a minus 10a minus 50, which is fine when it's 10 minus 10. But often, there's a screw up right there in collecting your like terms, which is why I always stack them. So my like terms stay together, which you people have seen as well when I reviewed polynomial multiplication with you. If you stack it, you can't screw it up. So people want to see E and F now, yes? So E x plus 5 equals 36x. What bothers you about E? You don't like the fraction. You're scared of fractions. I know you're scared of fractions. It's not your fault that you're scared of fractions. You've been allowed to be scared of fractions. I don't know why. You all know how to do it, though. If I gave you this, x over 2 equaled 15, how do you get rid of that 2? You multiply both sides by 2. So, if this scares you, get rid of it. How do you get rid of this x? Multiply that side by x. They disappear, and now I equal 36. But if I multiply this side by x, what do I have to do to this side? Multiply it by x. Then I just distribute. X squared plus 5x equals 36. Now it looks like something we're comfortable with. And all I do is factor it the way I always have. X squared plus 5x minus 36. And the factors are, of course, oh, that's the answer. Yes. The factors are, of course, x plus 9, x minus 4. And I know that my answers are then negative 9 and positive 4. Yeah, yeah? Yeah, yeah, yeah. I'd like to choose a funky color for this last one. Rose. I'm a fan of rose. When I think rose, I don't think that. Two x minus 1 equals x plus 1 over 2x. What scares you? The same thing that always scares you. It's been scaring you since the 4th grade when you were first shown them. Fractions. How do you get rid of fractions? The same way you've been getting rid of fractions since the 7th grade when you started doing algebra. You're going to multiply this side by what? 2x, so you can cancel it. If you do something to the right, what do you do to the left? The exact same thing. It's almost like there's a pattern to it. Weird, hey? Math being the same thing every time, being all ordered and logical. Screw you, math. World's not like that. 4x squared minus 2x equals x plus 1. And then I do the same thing I've always done. Collect my like terms by moving everything to one side. 4x squared minus 3x minus 1 equals 0. I need to multiply to negative 4 and add to negative 3. What is it? Plus 1, x minus 4, but that's, of course, over 4. That simplifies to 1, and my answers are negative 1/4 and positive 1. Everybody good? And of course, remember, I wanted you to keep somewhere near the top of your brain that thing we started with today, the graphing, right? So every answer we have found here, no matter what it is, are dots on which line? The x-axis or the y-axis? On the x-axis. Every one of these numbers is a dot on the x-axis somewhere. All right? Everybody cool? Going once? Going twice? Going thrice? Spectacular! All right. You have a page in your book, back a couple of pages, that looks, I can't remember what page number it is. It is page maybe 65. No, it is page 67. That is blank. Some of you would have used that yesterday for that extra work we did. And 68 is also blank.
And as well as 69.
Yes, I left 3 or 4 blank pages here because this is always a problematic unit, the radical equations. A bunch of you have probably done some work in there, and then there's the page that says test review or whatever. It's page 70 or I don't know, whatever the heck it is. It doesn't matter. On your test tomorrow, you will be expected to be able to multiply any levels of polynomials. Why? Because it's all the exact same thing. No matter how big I make the polynomials, it's always the same thing. If it's this, you're going to distribute once. If it's this, you're going to distribute twice. If it's this, that's a horrible color. You're going to distribute 6 distributions. And it doesn't matter how big I stretch it. It's always the same thing. If you insist on doing this the way your grade 9, 8, 7 teacher taught you and writing it all out in a line, you're going to get a long line of stuff with a lot of like terms that can be a real pain to collect. But if that's what you're comfortable with, do that. If you find you often get the wrong answer when I hand you back your test, should you continue to multiply your polynomials that way? No, because you're doing it wrong. All right? Figure out another way. The other way that I have given you is the stacking method. Do I need to go through it? Or is everybody comfortable with their ability to multiply polynomials? We're all happy? Even if I gave you one of these, you'd even be happy there? Of course you would, because it's just the same thing. You're going to distribute the x, you're going to distribute the 3x, and you're going to distribute the 7. Right? Okay. The number one mistake you guys make is this. Negative x minus 2 times x squared plus 3x minus 4. When you bring that to there, you are going to forget that the last term is needing to be positive 8. You're going to forget that negative sign. At least some of you. Be careful. Remember, you are not distributing minus 2. You are distributing negative 2. Right? Everybody good? Okay. We can all factor everything. We've just done a bunch of factoring. The factoring that we haven't practiced in the next unit is cube factoring, because we haven't talked about it a graphic cube, and you won't in grade 11. So if I give you this, x cubed minus 64, you remember how to factor that? There's a formula. You can learn it. And it is what? X minus 8, 4. Because it's cube roots. Then it's x squared. It's a minus, so it's plus 4x plus 16. And if it was this, y cubed plus 125, what would it be? Y minus 5 plus 5 y squared minus 5y plus 25. Right? What if it was 2x cubed and 128? What would you do? Of course you would divide by 2. You would GCF. And then what would be out in front of this mess? A big 2. A coefficient of 2. Yeah? What if it was 8x cubed minus 64y cubed? Oh, stop it. What would the first thing you would do be? You'd GCF out an 8. And 8, and then I would have x cubed minus y cubed, which would be 8x minus y, x squared plus xy plus y squared. Yo. Oh, thank you. This would be an 8. So this would be 2y, and this would be 4y squared, and this would be 2xy. Thank you. Yeah? Everybody? Yeah. Okay. And then the last thing that causes you guys the most fear is a radical equation with that. Right? That bothers you. Doesn't matter what the rest of the equation is, that scares you. How do you get rid of that? Jack? Square it to get what? Q minus 7 over 3. How do you get rid of that? Multiply by 3 to get q minus 7. If you do that, everything else in the equation must be squared and multiplied by 3. Then you can do it. Right? I reminded you yesterday, on your test tomorrow, you will always be able to factor to get the proper answer. Okay? In 3 or 4 days, you will not always be able to factor. But you will have the tool you need to solve them. Okay? But I am building up to that. I have my reasons, trust me. Caio from Brazil is like, screw you, why don't you just show us that in the first place? And he's right, except, again, I have my reasons. When you see what the tool is, you'll be like, damn, I don't want to use that unless I have to. Okay? Everybody good? All right. I got 9:15. What do you guys need from me right now? Do you need silence to prepare for your test tomorrow? What? You have 15 minutes. I don't know. I do not care what you do. If you need some more questions, I can write some radical equations on the board if you want to practice it. It is totally up to you.
Can you make like the hardest question possible you'll put on the test and help with it?
Sure, I can find some difficult ones. Let's find a nice, hairy, difficult one. Sure. Try that. And oh, just for fun, even though it won't be on the test. Cube root? Stop it! Yeah! Yeah! Oh no, I left the radical sign. Have no fear. Whew! Those are toughies.
Pretty crazy.
Those are toughies. you should expect anything on the test tomorrow. The only thing that I will tell you about on the test tomorrow is that you will not have any that don't give you a perfect number. You will be able to factor everything. I think. Well, no, on the test you will be. No. Well, there might be. You might be able to factor them, but they may not work in the equation. Yeah, there might be. There might be some that the restrictions don't work. What? I'm going to run out of room. I need more room. I'm running out of room. Yeah, I'm out of room. I'll have to come back to that one because I want to keep them all on the screen for everybody. Oop.
This is a big line of numbers.
Yeah.
No like terms.
Oh, there's some like terms.
Yeah, a little bit. 6 different like possibilities.
These ones are easier. I'll just do these, then I'll come back to that one. No.
You don't think this is solid? I couldn't like. I'm gonna go back to like this. Maybe I could like move this out over here and then take out X. Does that work? So move the 16. Took out X on this side. Did everything. And then the edge. 65. But then.
That's not right. I screwed that up. Oh well.
This first one you did was kind of crazy. I don't think it's on. Like, this is really fast. So, how would I have done this? Like, I had just a bunch of, like, variables. All sorts of things.
Yeah, but notice 9, 6, 24. There's all kinds of factoring you can do up there, right?
Yeah, so I try to move the 16.
Yeah, you can group stuff and factor it. But you're right that it's over X. That will break down more.